Okay, so up to now, we have been finding derivatives from the definition, right, using the limit as h approaches 0 of f of x plus h minus f of x over h. The question we're going to look at now is, can we find derivatives without having to compute limits? So can we develop rules of differentiation so that we can find derivatives much more rapidly and avoid limits altogether? And you'll see the document that I will provide you in class. You will have, for each rule of differentiation, you'll have at the end of the document the proof for that given rule. So you'll actually see why the rule is true. In this video, we'll look at what are the rules and examples of applying them. The first rule is the simplest one, and that is, what is the derivative of a constant, right? So if you think of y equals a constant, what you have is a horizontal line. And the slope of a horizontal line is 0. So naturally, the derivative of a constant is 0. So examples of this would be, well, what's the derivative with respect to x of, say, 5? Well, y equals 5 is a horizontal line, the slope is 0, the derivative is the slope, so the derivative of 5 is 0. You could say, well, what's the derivative of pi? Same thing. Pi is a constant, the slope of a constant function is 0, hence the derivative is 0. You could say, what's the derivative of root 2 over 3? Same thing. Root 2 over 3 is a constant function, it is a horizontal line, it has a slope of 0, hence the derivative of a constant function is 0. And that's the constant rule. The derivative of a constant is always 0. Then we have a really nice rule called the power rule. And the question is, if you differentiate a power of x, how does it work? So here n is a fixed number, and we ask, if the function is f of x equals x to the n, what is the derivative with respect to x of x to the n? And the power rule says, and you'll see on the document, what we have at that point will be a heuristic. We'll find the derivative of x squared to be 2x, the derivative of x cubed to be 3x squared. So every time it looks like we bring the power down, times x to the power minus 1. And that is the so-called power rule. To differentiate with respect to x, a power of x, all you have to do is bring the power down and subtract 1 from the exponent. And you could replace x by any other variable, right? You could say I could differentiate with respect to t. If the function is a function of t to the n, and you're going to have n times t to the n minus 1. X is an arbitrary choice of variable, so you can change the variable for t, for u, for any other variable of your choice. Let's look at some example of this. Some examples. So what if we asked, what's the derivative of x to the 6? Well, it's x to a fixed power. The power rule says we can bring the power down, so it's 6 times x to the power minus 1. 6 minus 1 is 5. So it's just 6x to the 5. No limit. That's it. We could ask, what's the derivative of x to the 11? Well, it's x to the fixed power, so bring 11 down, times x to the 11 minus 1, 10. And that's it. We could ask, what's the derivative with respect to w of w to the 13? Right? We differentiate w to the 13 with respect to w. The power rule says bring the exponent down. W to the 13 minus 1, 12. What about square root of x? Right? So if we ask what's the derivative of root of x, all we have to do is rewrite root of x as an exponent. So the derivative, root of x is x to the 1/2. And now we can apply the power rule. we look at the derivative of x to a fixed power. The power rule says bring the power down 1/2, x to the, subtract from the exponent 1, 1/2 minus 1, that's negative 1/2. And if you want, you can rewrite this as 1 over 2, and if you send the x to the negative 1/2 down, the power becomes positive 1/2, and a power of 1/2 is just root of x. So 1 over 2 root of x. Okay. What about the derivative with respect to x of the cube root of x? Same thing. Rewrite the cube root as an exponent of a third. Once again, we have x to a fixed power, so we bring the power down, subtract from a third 1, and you get negative 2/3. And that's a derivative of cube root of 3. What if we have, say, a fraction? What if we have the derivative of 1 over x to the 7? Right? So this is not directly x to a power. Well, if we bring x back up, this simply becomes a derivative of x to the negative 7. And now we can use the power rule. Bring the exponent negative 7 down, negative 7, x to the negative 7 minus 1, negative 8. You can leave your answer as negative 7 to the times x to the negative 8, or if you prefer positive exponents, send the x on the bottom, and the power of negative 8 becomes positive 8. And that's the power rule. One last example. What if we look for the derivative of, say, x to root of 8? Well, we have a stranger exponent, but root of 8 is a constant, so we can apply once again the constant rule, the power rule, sorry. So we can bring the exponent down, root of 8, times x to the root of 8 minus 1. And that's the power rule. So now we can differentiate a constant. The derivative of a constant is always equal to 0. If you differentiate the power of x, you bring the exponent down, and you subtract 1 from the exponent. Now you can ask, what about the derivative of a sum of two functions, or a difference of two functions? So what if we have the derivative of f of x plus g of x? Or what if we have the derivative of f of x minus g of x? Well, the result says that the derivative of a sum or a difference is the sum or difference of the derivatives. So this will be the derivative of the first function plus the derivative of the second function. And we can write this slightly more concisely because the derivative of f of x can be written as f prime of x, and the derivative of g of x can be written as g prime of x. Same thing, but it takes a little less writing. Same for a difference. The derivative of a difference of two functions will be the difference of the two derivatives. And we can write this as f prime of x minus g prime of x. Let's look at a few examples. So what if we said, let's find the derivative with respect to x of x cubed minus x to the 4 plus x to the 9. Well, we look for the derivative of a sum of three functions, this function minus this function plus this function, and the derivative of a sum or a difference of functions is the sum and difference of the individual derivatives. So, we first differentiate x cubed. We get, with the power rule, 3x squared minus the derivative of x to the 4, that's 4x cubed, plus the derivative of x to the 9, power rule again, 9x to the 8. And that's the sum difference rule. The nice thing is, if you differentiate over a sum or difference of functions, you differentiate each function directly. And if you subtract, you subtract. If you add, you add. That is the sum and difference rule. In our next video, we'll look at other rules of differentiation.